What's poppin', dogs? It's Mr. Allen with some inverse functions. We got to show that each pair of functions we have here are inverses of each other using compositions. So we have to use compositions. So what does that mean? And then I'm going to get back to some specific wording in here that's very helpful. So we got f of g of x, that's a composition right there, is equal to x. And if we have g of f of x is equal to x, then they are inverses, okay? They're inverse functions if the compositions both equal x. Now here it says, okay, I'm going to go back to the wording here, show that each pair of functions are inverses of each other using compositions. So it's telling us that these are inverses. So when I do this work, I better get x for both or I made some kind of a mistake, all right? It could also be worded as determine if they are inverses of each other using compositions, and then they may or may not be both equal to x. But I know they're going to both be equal to x here if we do our algebra properly. So let's get after it. First one here, we got f of g of x. That means I need to take this guy right here and plug it in for my x right here, okay? So for f of g of x, I'm going to start over a little bit more. F of g of x equals, I got my f function, boom. We got square root of x plus 1 minus 3. That's all going in for x right here. I'll even put a second set of parentheses. Then we got plus 3. It's a terrible 3. Squared minus 1. Now I'm going to do some algebra. So these parentheses don't really do anything here. I'm going to just take them away, and we'll do this in a couple steps here. Minus 3 plus 3. Squared minus 1. Here my negative and positive 3 cancel, right? And now I have the square root of x plus 1 squared minus 1. Well, what happens with my squared and square root? Gone. And now I have x plus 1 minus 1, which equals x. First one, good to go, right? This is f of g of x equals x. Cool. So first one is a go. Check. Now, let's get the next one. I'll change markers here. I'll go with pink. Now I need to do g of f of x. So g of f of x equals, well, now I'm taking this whole thing right here and plugging it into just this x right here, okay? So we have the square root of, I need some room there, right? And I'm going in for x here, so I'm going to put a set of parentheses, and then this whole thing goes in. So x plus 3 squared minus 1, that's my x, and then we have plus 1, and then minus 3. It's easy to get lost in the sauce here when you're plugging in stuff for x and it's got like a lot going on, so really double check. This is my whole quadratic that I had x plus 3 squared minus 1. Cool, I like that. We still have the plus 1 present in the radical and the minus 3 outside. Excellent. Now let's clean this thing up. I'm going to run out of room, so we're just going to take care of these ones right here. And now I've got the square root of x plus 3 squared minus 3. What happens with the square root and the squared? Boom, they're gone. I've got x plus 3 minus 3. And now I've got, boom, x. So g of f of x is equal to x. Checkmate, right? They are inverses of each other because they both equal x. I'm going to put a check mark here and here. Check marks all over, man. That's awesome and wonderful. One thing I did want to note here is look at this domain restriction, right? We needed that, right? Because otherwise they wouldn't they wouldn't be inverse functions of each other, right? I have to restrict this domain here. X is greater than or equal to negative 3. That gives us the positive square root. If this was x is less than or equal to negative 3, you'd see a negative right here. Okay? So domain restrictions are important when you're dealing with even degrees and other situations as well. You'll see domain restrictions from time to time when dealing with inverses, okay? It was nothing that we had to really do as a part of this problem, but it's still there. And I feel like a lot of times when something like this is a part of the problem in the instructions and whatnot, we get kind of confused. SAT and ACT throw out a lot of domain restrictions to make sure that the functions are defined, but it really doesn't play a role in any of the math that you're doing. So get used to seeing some of those things. It's a little more formalized, okay? So there we go. First one's done. Now let's go over here and we'll get after it with this one. I'm going to start with orange in this one. I'm going to switch with the colors, man. All right, so first thing I got to do, same process. Let's go with f of g of x. So f of g of x equals, So that means that I'm taking g of x and I'm plugging it into this x here. So I will have, and I like to put it in parentheses when I do this substitution here, because then it reminds me, hey, that's going in for x. And if there's multiple x's, sometimes, you have to plug it in multiple spots. And I like to show that if anything's squared, then we got to, that's got to be raised to the same power. All right, there we go. So now we got 5x minus, there's nothing happening with this parenthesis here. So we're going to just do 5x minus 2 plus 2 over 5. 2's cancel. We got 5x over 5. Cancel equals x. Boom. F of g of x equals x. First part done. Next one. I'm going to go with neon yellow. It's not very contrasting. I'm going to go with blue. All right, we're going to go blue. Now I want g of f of x equals, so here I'm going to take the f of x, this whole bit right here, and put it in for just this guy right here. So we got 5 parentheses. This is where the parentheses are definitely going to be playing a role here, right? X plus 2 over 5, then minus 2. So the 5 stays, the negative 2 stays, that x becomes my f of x function. Bibbidi-bop. So now with these parentheses here, what's going to occur with the 5 and the 5? Well, those are going to cancel, right? Because it's 5 in the numerator, 5 in the denominator. They divide out. And I've got myself x plus 2 minus 2. 2's cancel. We got x. So g of f of x equals x. You may be asked to prove one of these, okay, on a test or a quiz. So you've got to show some work here. You can't just be like, oh, yeah, it's good. It's fine. No, you need to show the substitution here, some algebra, getting down to that final equals x. Same with this one here. All right? If we were determining whether or not they are inverses of each other, and you happen to get one of them is not equal to x, you can stop right there, okay? But if the first one equals x, then you got to check the second one, all right? But for these, we knew they were inverses because of the specific wording here. Show that they are inverses using compositions. That's implying that they are inverses, that they should both equal x. Got to do all that work. You know what? I didn't put any check marks here. Check. Check. Now we're good. Now we're good. All right, you guys have a great day. Hopefully you love this because compositions are just kind of a pain, but got to do them. You got to do them to show that they're inverses. See you later.